I'm here to introduce the next speakers. We have Konstantinos Sidiropoulos, software engineer, test and infrastructure capability lead, Agile Actors, and we have Athanasios Papaioannou, AI engineer, Agile Actors, and we're going to talk about beyond the hype, how does RAGAS measure real LLM impact? Please, warm welcome. Just a reminder for everyone, we also have a Q&A session in the end after this talk, so you can also prepare your questions. Thank you.
Okay. Thank you, everyone. Very nice to be here in Disrupt AI Summit. Let me first introduce myself. I'm Konstantinos Sidiropoulos. I'm a software engineer, test and infrastructure capability lead in Agile Actors. This one stands for SETI, but it has nothing to do with extraterrestrial intelligence, right? And next one is Athanasios. Athanasios, do you want to introduce yourself?
I will do it afterwards. Just go on.
So Athanasios is our AI engineer in Agile Actors, and this one we're going to present on how we can use RAGAS in order to measure real LLM impact. So before we start, talking and discussing about RAGAS and everything, I just want to tell you a story. So all these things started when I was having one problem, and my main problem was that in one of the products that we were working on, this one was AI-driven. So I had to find a way in order to test this AI-driven application. So this one, as you understand, was having a lot of challenges, more challenges than the traditional software. One of them was, of course, and the main challenge that I had there was that it was very difficult to test and evaluate this, actually. I will stop using the word test. I will now use from now on the word evaluate because of the nature of the application. And the main problem was that the lack of objective ground truth. So it is not like traditional software where you have deterministic input and you have deterministic output, and everything is fine there, or close to fine. So AI responses can be subjective. Of course, we have, and I had other kind of problems with hallucinations and misinformation. So the AI application, it would generate false but convincing answers. And of course, we had the problem with the context dependencies, that responses could vary based on input phrasing and the scalability issues that we mentioned here. So we had all this problem. It's a brand new area. And then I had to go back and talk to my friend Athanasios and say, okay, Athanasios, I'm having this problem. How I'm going to tackle this one? And then suddenly Athanasios came and said, okay, we have RAGAS. And now I will let the stage to Athanasios, who is more expert here, and he helped me a lot in order to try to solve, let's say, the problem. So, Athanasios, what was RAGAS?
Okay, so before saying things about RAGAS, I was looking at so they asked me to give a photo for the summit, right? And I was looking at some of the photos I had taken like a few years ago, and then I took a photo a few days ago, and I saw the comparison. Oh man, that's what AI testing does to people. You're so much older, suddenly. Anyway, yeah, so I guess it all starts from the non-deterministic nature of the LLMs, right? So instead of having a specific performance, we rather have a performance range. And when we're like in this honeymoon period of trying to come up with a pilot or a POC, it is the point where we don't necessarily care a lot about the floor of this performance. We'd rather try to build something that works. So we're more interested in the ceiling. And this is the point where everything goes well. But as we move closer to this tipping point of going closer to production, there comes the point where we don't necessarily think a lot about what the LLMs do at their best, but rather what they do at their worst. And this is a scary point, really. And this is where evaluating these LLM pipelines comes into hand. So what is RAGAS? RAGAS is one of the most popular frameworks for evaluating LLM pipelines. And it has a huge emphasis on RAG applications, but this is not exhaustive. I mean, you can use it for other evaluation, for evaluating other components as well. And RAGAS has certain advantages. One strong one is the focus on faithfulness, correctness, and relevance. Another one is that it bridges the gap, especially with RAG pipelines, it bridges the gap between retrieval quality and response quality, which is not necessarily a given for other evaluation frameworks. And my personal favorite, it offers a high degree of customization in various areas. So especially when you use metrics that utilize the LLM as a judge principle, you can customize those metrics a lot, you can change the prompt, you can come up with your own metrics if you feel very confident about some of the heuristics that this brings to the story. But anyway, it does have some certain advantages which you can utilize in order to tackle this problem of going past the non-deterministic nature of the LLMs. And when I seek various areas, obviously, as I mentioned before, RAGAS is very well positioned to evaluate RAG pipelines. So this is well established by now. We have a vector or some other type of database, and we try to retrieve some information. Given an input query, we try to retrieve some information from this vector database, and then given this retrieved context and some guidelines that we have given to the LLM, we try to generate a specific answer. And so RAGAS is really good at bridging the gap between those two separate processes, so to speak. And there are a lot of metrics associated with these two specific components, and by combining them, we can tell the story and we can tackle specific problems through this process. But as I mentioned before, it is not only used for RAG, it is very well positioned to be used for other, even simpler pipelines, such as just a summarization task or a translation task. So it does have a lot of metrics that try to tackle natural language comparison issues, such as we have a given answer and then we have a few references, and we try to come up with a few metrics that try to evaluate how close are our answers to the ground truths. One of my personal favorites, and I think this is the bit that will become more and more popular the next few years, is the agents and tools component. So RAGAS does offer a lot of metrics that try to break down complex pipelines, such as ones with multi-agent systems, and possibly these agents might have a lot of tools. So given an input query, we might need to route our application to call a specific agent, and then we have to call a specific tool from this agent. And this can be quite complex, right? It does require a lot of prompt engineering and possibly a lot of optimization in the functionality of the tools themselves. So RAGAS does offer the capability to control to evaluate first how well those decisions are taken within the context of our application, and then tackle any problems that come up. And other more specific stuff, let's say we have a text to SQL pipeline, so we have some natural language, and this is translated into some SQL query that's going to be used to retrieve some information from a relational database. So RAGAS does offer the capability to see how well this translation is materialized, and also other customized stuff. As I mentioned, this is one of its propositions, really, the fact that you can really come up with your own metrics or possibly tweak the existing ones to some extent. So the way RAGAS has been formed is that it has a main categorization of metrics, right? And this is the LLM-based metrics and the non-LLM-based ones. So the LLM-based ones, I mean, they use this LLM as a judge principle, which is quite scary, really. So it might introduce a lot of bias, so it shouldn't be taken into a vacuum, so it obviously needs a lot of context, but it is really fast and scalable. So these are its main advantages. And then we have some other metrics, the non-LLM-based ones, which are far more explainable. They're very robust, but they don't really scale very well. They can be quite slow. So, as you might imagine, typically, the situation is that we need a hybrid approach, so some LLM-based metrics, some non-LLM-based ones. And this obviously depends on the point in this AI journey that we are. Maybe it is very early into the process, and then we want to have some very fast results. So it might be the case that we wanted an evaluation that runs into a few minutes. But then if we're like further down into this journey, we might need like some really robust evaluation metrics before we push into production. So maybe we need to give some more weight towards the non-LLM-based ones. Just as a reference, some very famous LLM-based ones is the GPT score. This is the most generic, really. You can give the GPT score any criteria that you like, and this will use an LLM in order to evaluate the response from another LLM. We've got the faithfulness score, the answer relevancy, and the fluency score. These are all metrics that tackle issues such as the relevance of the final answer to the input query, or the extent to which the final answer is an answer that would be given by a human. And the tool call and agent call accuracy. Again, this comes back to the agentic stuff that I talked about in the previous slide, where we can quantify whether our application has taken the right decisions as to what agents should be called, what tools should be called in order to have the outcome that we want. Some non-LLM-based ones, the precision and recall, they're very famous metrics. They're used in RAG applications quite extensively. And then we also have the blue and the rouge score, and the human annotation, which speaks for itself. It's basically having experts give some ground truths, and based on these ground truths, we can tell whether our expected outcome is close to the actual outcome that we get. But this is not the only categorization that we have, and I think at this point, Kostas, you wanted to speak a little bit about some metamorphic testing.
Yeah, so
it's quite scary, it sounds.
Yeah, it sounds scary. So in the meantime, when Athanasios was explaining to me about RAGAS and all the metrics, so I had something at least that was quantitative that I could rely on. So in the meantime, as I was saying, I was doing my research, and I came on this term, which is called metamorphic testing. It's a relatively new field in the academia. I think that it was in the late 90s that was introduced. In the industry, it's mostly used in other areas. I think that Google is using in order to test the graphics for the Android devices. But this one has now somehow emerged, and probably it's going to be used in the future because it can be very helpful when we want to evaluate or test, let's say, some AI-driven application. So if you want to, let's say, explain it in more plain words, the main problem that we have is that it is not easy to define, as we say in traditional software, the test oracle, which means that in traditional software we have the input and we know the expected output. So in AI-driven application, it is not very easy for us to have the expected output. So what we can use and what this technique is used is in order to be used for the ground truths, for the, let's say, expected output. So this one focuses on, as we say, on consistency and logical correctness. But if someone asks, what is this actually? It's mostly that we use certain inputs, we get the expected out, the outputs, and then we try to do some changes in the input, and based on these inputs, we want to see how the output is changing. One small example is here. So we could ask, let's say, an LLM, and ask this LLM, so who is the CEO of Microsoft? We get an answer, and then we change this question, and we say, now, who leads Microsoft? And we expect that we are going to have the same output as before. If we have different answers, of course, this one might, as we say, indicate some consistency issue. So the main issue here is that we try to build relations. Imagine that we have a list of numbers, and we give it to an LLM and say, what is the mean value of this? So if we go then and change this input of this list of numbers, and we say, okay, we'll multiply all the numbers by, let's say, twice, then I would expect that I will get the previous output, but this is going to be twice the value. So the whole thing is that we try to have relations on the input, and based on the changes that we have on the input, we try to have the changes on this output. And of course, we could, let's say, use the metrics that Athanasios proposed to me with RAGAS before, and try to get some of this value. Most of these metrics, if I remember correctly, they are quantitative, so they would have some values like between 0 or 1, or some of them could be exactly 0 or exactly 1, so it's true or false. I don't know if you have, so in the previous question, if you could propose me some of the metrics that I could use.
Yeah, I mean, my personal favorite is the tool calling one. It is between 0 and 1. Hopefully you don't get a lot of zeros. Sometimes I do. And I guess some of the most prominent ones are the faithfulness, the precision and recall, as I mentioned. They do a pretty good job of telling whether the retrieved context is actually useful for the final result. But I think I'll talk a bit more about them in the next slide. So
okay, great. So this whole thing, of course, was inspired by some real case that I had to tackle, but also with a real case that Athanasios had tackled before, which is in the next slide. And of course, this combined, let's say, knowledge, with this combined knowledge, we managed to solve our problem. So the next case, which is a real case, is something that Athanasios was tackling.
Yeah, so instead of just shooting you with metrics that very few people are going to remember, and then again, you can always check them afterwards, so it's not really a big deal, I thought it would be a good idea to just show an example, right? Let's say, and it's not a business-specific example, but rather in terms of the pipeline, it can be a real case for various businesses, right? So let's say we've got a chatbot, and we've got a fairly complex and challenging RAG case study. So let's say that we want to get information that are stored in some documents. So we have the typical vector RAG, we vectorize the documents, and then we use some embedding model and store them in a vector store. And then let's say that we also have some information that is stored in a graph store. So we make either a multi-agent system where each agent has the job of looking at the specific database, or we might have just one agent and have a specific tool for each one of the searches, right? Either way, it's a fairly challenging RAG case study and involves having to route the application to use the correct database given a specific input query. And next to it, I have come up with a few metrics I mean, I've put a few of them, but really I would like to talk about some specific ones. Like, for example, I've got the faithfulness, the noise sensitivity, the precision with reference, so that is having ground truths, the precision without reference, so measuring the precision without having any ground truths, the precision without the LLM, so the two previous precisions do utilize an LLM to come up with a metric, whereas the precision without LLM, it is totally deterministic. The blue score and the tool call accuracy. And I would like to focus on the precisions and the tool call accuracy. Before going there, I think, as you might have noticed, I've put in some average value on the second column, right? So generally, it is a good idea when evaluating the LLM pipelines to try and run them a few times. So maybe we can throw away some of the bias by coming up with some average values. But it is really important to also have a look at the discrepancy between the minimum and the maximum value at each of these runs, right? So let's say that we have a few questions for this chatbot, we run these metrics, and then, as we see in the precision without reference, we've got a minimum value for one of the runs, the precision was 0.45, and in another run it was 0.9. So that pretty much says that we cannot really trust this metric a lot. So it is generally good practice when evaluating these pipelines to also look, to have some average values after a few runs, but also look at the individual values for each one of the runs, right? Because for some of them, it might be the case that we cannot really trust what they come up with. Now I would like to shift the focus to the tool call accuracy. So ideally, it would be a huge success if we could alienate a specific module and have one metric that can really tell the story of whether this module works well or not, right? I mean, this is the dream. It is rarely the case, to my experience, but it can be the case. And for this specific application, this tool call accuracy, so let's say we have one agent, and this agent has two tools. One of the tools looks at the vector store, and the other one looks at the graph store. So this tool call accuracy metric, what it does is that it tells the story of how often the agent takes the correct decision to use each one of the tools. It might be that it has to look at the vector store, the graph store, or both of them, right? So in this case, I've put a value of 0.6. So what it means is that 40% of the times, given an input query, our agent does not take the right decision to utilize one of the specific tools, right? So obviously, this is not the way forward. We might have to change the prompting a little bit, or maybe this means that we cannot trust the LLM to take this decision. It might be that we have to replace this specific decision with some more deterministic function, or maybe a deep learning-based approach. So this is one case as an example of how we can really alienate a specific module within our wider pipeline, which can be evaluated based on one metric. But as I said, this is very rarely the case. Typically, we have to combine a few metrics in order to be able to tell the story of whether a specific module works well or not. And for example, if you look at the precision without reference and the precision with reference, so what the precision does is that it quantifies how much of the retrieved context is actually used in the final answer, right? So let's say that we have retrieved some documents and then we have an answer, how much of this information was used for the final answer. And so it does that by grabbing the retrieved context and either looking at the reference values, the correct answers, or looking at some of the generated answers. In any case, the context is the same. So if we go back to these values, and let's assume that these values, we can trust them, the 0.9 and 0.62, which is a big if, but let's say that we can trust them. The fact that we have such a huge discrepancy between these two values, it basically means that we have a prompting problem, right? Because in the first case, we have our retrieved context, and it aligns very well with the real answer. Whereas in the second metric, we have the exact same context, but it doesn't really align very well with the generated answer. So what does that mean? That means that we get the right information, but the agent doesn't have the capability to answer in the right way. So this is just another example of how we can combine a few metrics to tell the story of what goes wrong within our pipeline. So this is pretty much it with the example. And as we move closer to the end of our presentation, I think there are a few key takeaways that we can get out of this 30-minute talk. So RAGAS offers a platform, and it really is a platform because it has this high degree of customization. Offers this platform based on which one can evaluate various bits and pieces within an LLM-based pipeline. A hybrid metric approach, as I mentioned earlier, so using both LLM-based and non-LLM-based metrics is strongly encouraged, and that obviously depends on a few factors. The metamorphic testing, which Kostas is really excited about, it can help ensure robustness by testing against this case sensitivity. And obviously, combining different metrics can help alienate the root causes for poor results. So that was pretty much it. Thank you. And if you've got any questions, we'd be happy to answer.
We have one question there. Yes.
Hello. Very nice presentation. I would like to answer to a question. What is the requirements to deliver to the client? Does the client says, for example, that wants tool accuracy 0.6 or 0.7?
Yeah, so can you repeat the question? Because I didn't...
Which are the requirements
right.
to deliver to your client?
Right, so I guess this also depends on the use case, and I guess this is also like, I guess the answer to this question, it depends on like the internals of the application. It's not as if there is some golden rule of that you have to have like a 0.9 in order for it to be a good metric. I would say that the metrics that I showed are not really good, so you wouldn't go to production with this kind of metrics. I think it's more of having a few metrics that you're really interested about and you want to optimize those ones. I wouldn't say that there are specific values that you can say that above 0.9, this is a good metric. I would say that it is dependent on the situation. Yeah. Sorry that I don't have like a more concrete answer, but yeah.
Do we have any other questions? Yes.
Yeah.
Maybe we have a question there.
Thank you again for the presentation. About the quality of the models, because it's...
Sorry, I can't hear you very well.
Is it now better?
Yes.
Okay.
Yeah.
Given that the quality of the models is of paramount importance, the solution presented, you mentioned, that uses metamorphic testing, which means that we need variation in the input. Given that we have an input that is specific, the variation must be introduced by the user himself, or the solution generates the variation. If the case is the latter one, how do we know that this variation is sound?
Do you want to take this one?
Yeah, so this is combined question, I think. So of course the input is something that you give yourself. And this is what you would do actually in traditional software testing, even unit tests. You give some certain values and you know the expected answer. Of course, now you need to and this is the most challenging part, to try to find this kind of relations. And here we gave some simple examples, but of course in more complicated systems and more domain specific, you need to find this kind of variation, and this is where the whole exciting thing starts. So if you try, of course there are ongoing research on this topic and the domains on how you can find proper variation. So if I wanted, to try to find something now that I know, for example, we gave there the example with the CEO of Microsoft, and we tried to do some changes there, so who leads. Of course, the output is going to be, let's say, the actual output it will be different, most probably. But context-wise and conceptually, this is going to be pretty much the same. And this is where we could use the metrics of RAGAS, where we could get, the values and try, as Athanasios mentioned before, we don't have certain values with the metrics of RAGAS, but it could be, let's say, limited in certain areas. So above, you define it. You say that I want it above, let's say, 80%. So I make the variations on the input, and then I check what is the changes that I get with the RAGAS metrics, and I expect them, of course, to be above certain point. Hope that I answer your question.
Yes, thank you.
Maybe we have one more question here.
Yeah.
Hello. So at one of your slides, you mentioned that, let's say, the prompt to the AI is, the input is, who is the CEO of Microsoft, let's say. So a paraphrased input could be who runs Microsoft or any other company. So the answer to the second question could be different than the first one. Because, for example, given a different context, you could be referring to the shareholders or the stakeholders or something. So do we, in a way, limit the model to answer in a more deterministic way by imposing such relations? I mean, do we limit the output in a way?
Yeah, so I guess this is one of the things that we want to try and impose, right? I mean, there are obviously ways to try and make your output more structured. So I guess it's just a process of adding some variation yourself and trying to understand whether the ways you have come up with in order to induce some structure and some, let's say, determinism to the answer work, right? So, yeah, not sure if the question is whether what kind of ways we can use in order to impose some structure to the output, but generally this is what we want, right? We want to see whether the ways we have used in order to impose this structure work given some input variations. This is the whole point of the metamorphic thing, basically.
Thank you.
And this also has to do with proper prompting.
Yeah.
Right.
And not only.
Yeah.
Are there any other questions? Some people in the back, perhaps. You have Dimitris, he has to burn some calories, please. Let him run away. All right, I think that's it.
Thank you very much.
Thank you very much.